Welcome to the DIY Honda Garage channel. DTC P050B refers to a performance issue within the cold start ignition timing control system of the Honda Accord, specifically from the 2017 to 2023 model years. When this code appears, it indicates that the engine isn't managing ignition timing properly during cold starts, which can affect engine performance, fuel efficiency, and overall drivability. In the PGM-FI, Programmed Fuel Injection System, this issue can arise from various components and conditions. The PGM-FI system is vital for controlling fuel injection and ignition timing, ensuring the engine runs smoothly and efficiently. Key components involved in this diagnostic trouble code include the engine coolant temperature (ECT) sensors, mass airflow (MAF) sensors, and the idle air temperature (IAT) sensors, all of which played essential roles in measuring and managing air-fuel mixture for optimal performance. Their failure can lead to erroneous readings, causing the ignition timing to be out of specification when the engine is cold. DTC P050B highlights a malfunction specifically within the ignition timing control system during a cold start. When the vehicle is cold, the ECT sensors measure the engine's coolant temperature, while the MAF and IAT sensors measure the air entering the engine. Their feedback is crucial as it informs the engine control module (ECM) how to adjust fuel delivery and ignition timing. The sensors are positioned strategically. ECT sensors are usually located near the engine's coolant passages. The MAF sensor is positioned in the intake duct, and IAT sensors are often integrated with the MAF sensor. A problem in any of these sensors can prompt the ECM to set a DTC indicating improper ignition timing control when the engine is cold. This issue may lead to starting difficulties, poor fuel economy, and rough idling. Several potential causes can trigger DTC P050B. A faulty ECT sensor may give erratic temperature readings, misleading the ECM about the engine's operating condition, ultimately throwing off the ignition timing. Additionally, if the MAF or IAT sensors are contaminated with dirt or debris, they may not accurately measure the incoming air temperature and mass, disrupting the optimal air-fuel mixture. Issues like blocked intake air ducts can also inhibit airflow, meaning the engine may not receive enough fresh air for combustion during initialization. Each of these faults may intertwine with other components in the PGM-FI system, necessitating a thorough inspection to isolate the culprit effectively. By addressing each potential issue methodically, technicians can ensure accurate performance diagnostics. Recognizing the symptoms caused by DTC P050B is critical for prompt troubleshooting. Drivers may notice rough engine starts, particularly on colder days when the vehicle hasn't warmed up. This trouble can manifest as stalling or sputtering immediately after starting the engine. Poor fuel efficiency may also accompany this DTC, as the engine struggles to balance air and fuel requirements due to inaccurate readings from the ECT or MAF sensor. Furthermore, increased emissions can occur, as improper combustion leads to incomplete fuel burning. These symptoms not only affect vehicle performance, but can also lead to more extensive and costly repairs if left unaddressed. Drivers should be vigilant if experiencing these issues to ensure timely diagnostics and repairs. The first step in troubleshooting DTC P050B involves bringing the vehicle to the on mode. This mode allows the Honda Diagnostic System, HDS, to communicate with the vehicle's onboard computer. Subsequently, technicians check for any pending or confirmed DTCs that may appear alongside P050B. It's essential to ascertain whether other DTCs exist, as this might indicate additional faults impacting system performance. For instance, if a different DTC shows up, the technician should follow the instructions for that particular code before proceeding. This initial check is crucial, as it helps identify if the ignition timing problem is a standalone issue or part of a broader system malfunction that requires attention. The second step in the troubleshooting process requires the technician to turn the vehicle to the off-lock mode, ensuring safety while inspecting components. Once in this mode, both visual and tactile verification of the intake air duct is executed. The intake air duct facilitates airflow to the engine, and any poor connection or blockage can severely impact how much air reaches the combustion chamber. Technicians should check for bends, kinks, or debris within the intake duct. If any issues are identified, repair or replacement may be necessary to ensure optimal engine breathing. If this inspection results in a confirmation that the duct is in good condition, technicians will proceed to the next step in the troubleshooting flow. Following the verification of the intake air duct, Step 3 involves inspecting the air cleaner housing. This component is responsible for housing the air cleaner itself and ensuring that clean air enters the engine. The technician must check for any poor connections or blockages, preventing air from passing efficiently. Damage to the housing, such as cracks or deterioration, can also lead to compromised air quality entering the engine. If any issues are discovered, the air cleaner housing should be replaced to ensure proper engine function. Once confirmed that all is in order, the troubleshooting moves to the next step, which evaluates the air cleaner element and its condition. Step 4 focuses on the air cleaner element's condition. The air cleaner element's primary role is to filter out dirt and debris from the intake air, ensuring only clean air reaches the combustion chamber. Should this element become too dirty or clogged, it cannot perform its function effectively. This can mislead the engine's sensors and compromise performance. The technician should visually inspect the air cleaner element for dirt or debris that impacts its filtering capability. If the element is determined to be dirty, it must be replaced to restore effective airflow into the engine. If it is clean, the process continues to evaluate the necessary thermal conditions in the next step. In troubleshooting Step 5, the technician must allow the engine to cool until the engine coolant temperature, ECT sensor 1, reads 122 degrees Fahrenheit, 50 degrees Celsius or lower. This cooling process is imperative for accurate diagnostics of cold start conditions. Once the vehicle reaches an appropriate temperature, the technician should use the HDS to clear any DTCs, allowing for a fresh read of the system. Next, the technician turns the vehicle to the off-lock mode and subsequently starts the engine. Monitoring the engine's performance in idle for over 10 seconds provides real-time feedback. During this process, the technician needs to monitor the OBD status for DTC P050B to ascertain if any faults re-emerge. This step aims to isolate whether the initial problem persists under these controlled conditions. Step 6 requires the technician to conduct a performance check on the MAF sensor. The engine should be held at 3,000 RPM without load, enabling the radiator fan to engage, followed by idling the engine. The technician will then need to keep the engine speed at 2,500 RPM for 30 seconds. During this period, monitoring the MAF sensor's parameters using the HDS is critical. Specifically, the technician should check if the MAF sensor readings fall between specified thresholds of 4.1 to 5.7 grams per second, G-seconds. If the sensor readings are within this range, the MAF sensor is functioning correctly, allowing the troubleshooting to proceed to the next step. Conversely, if the readings fall outside this threshold, Replacing the MAF IAT sensor is necessary to rectify the performance problem. The final troubleshooting step addresses the performance of the IAT sensor 1. Start by turning the vehicle to the lock mode. Then allow the engine to cool to ambient temperature for an accurate assessment. It is also crucial to note the ambient temperature during this phase for comparison. Once the vehicle is turned back to the on mode, the technician will quickly check the IAT sensor 1 value using the HDS data list. The key evaluation here is whether the IAT sensor's value deviates by 5.4 degrees Fahrenheit, 3 degrees Celsius, or more from the ambient temperature. If the deviation exists, it indicates a malfunction in the MAF IAT sensor, necessitating its replacement. If the sensor performs within acceptable limits, the technician must check for dirt and damage in the throttle bore, cleaning or replacing the throttle body as needed. This thorough approach emphasizes the importance of clean air pathways for proper engine performance. After completing all the troubleshooting steps for DTC P050B and making necessary repairs, it is critical to carry out final verification. Begin by ensuring that all DTCs have been cleared and there are no pending errors left in the system. Next, the vehicle should be tested under similar conditions that initially triggered the DTC to confirm whether the issue has been rectified. This involves starting the vehicle in cold start conditions and observing its behavior during idle and acceleration. If the engine performs well without any recurrence of DTC P050B, the repair can be considered successful. Comprehensive testing ensures that the ignition timing control system functions effectively, restoring the vehicle's performance. Documentation of this verification should be maintained for future reference. Preventive maintenance plays a vital role in ensuring the longevity and performance of the ignition timing control system. Regularly replacing air filters aids in maintaining optimal airflow to the engine by preventing dirt and debris buildup, thus taking a proactive approach to avoiding DTC P050B issues. In addition, checking the functionality of essential sensors such as the ECT, MAF, and IAT can help prevent unexpected failures while driving. Routine inspections of wiring and connections are equally important, as loose or corroded connections can lead to erratic sensor behavior and potential DTC triggering. By adhering to these preventive measures, vehicle owners can significantly reduce the likelihood of encountering P050B and improve overall engine efficiency and reliability. In conclusion, DTC P050B signals a significant issue related to the cold start ignition timing control system within the Honda Accord models from 2017 to 2023. Understanding the interplay between pivotal components such as the ECT, MAF, IAT sensors, and intake pathways is essential for accurate troubleshooting. Each step in the diagnostic protocol has been structured to pinpoint potential failures systematically. The lingering challenges posed by dirty filters, faulty sensors, and blocked air ducts highlight the importance of regular vehicle maintenance. Timely repairs not only restore engine performance, but also ensure driving safety and efficiency. The knowledge of these processes equips technicians and vehicle owners alike with the capacity to address and resolve ignition timing-related concerns effectively. Please like and subscribe to the channel. See you next time.